Hi guys, so today we're going to be comparing functions. So given this table, we're going to analyze if it's exponential, logarithmic, polynomial, or rational. So remember we have gone through all these functions already. For instance, exponential might be like 2 to the x power, whereas log, you're taking the log of a function to get y for each one, or in this case, f of x. Polynomial is anything you've worked with from Algebra 1 and 2, such as a quadratic equation. And then rational, we've also seen as an expression over another expression. I'm just making things up, obviously, like this will not be correlated to the values, but just so you know what type of function is which. So what draws my attention to this table is the only way that I'm going to input something as 1 for x and get 0 is if I'm dealing with a log, because remember that that's one of the key points of the graph. If you remember what a log graph looks like, I know that's not straight. 1, 0 happens to be one of the key points of a log parent graph. So this draws my attention to a log graph. However, for 1, how can I make it so that if I input log as 4, I'll still get 1 when I'm done. And just because with logs we're used to seeing the constant on the other side of the equal sign on the right, I'm just going to write it that way just to make things simpler. Um, the only way that that would happen is if I gave it a base of 4, because remember, you can rewrite this also in exponential form just to check. 4 to the first power does equal to 4. Or if you use the change of base formula, log of 4 over log of the base of 4 also gives you 1. So that means that from the first set of points that I'm given, if I type in log base 4 of 1, that should still give me 0, meaning if I use the change of base formula, taking log of 1 over log of 4. So you can plug that into the calculator. And anytime you take the log of 1, it's going to give you 0. So 0 over anything, so I'm going to leave it as log of 4, is still 0. So it works for this, and you can continue on. But once it works for 2 points, that's pretty much going to be your function. So it is a log function, and it would be log base 4 of x. We'll leave x and y as variables because remember you can plug any of these values in, and x and y represents any point on the graph itself. I wanted to show what that would look like graphically if I were to graph log base 4 of x. So with Desmos, I can't actually type the base in, or that I know of. Please let me know if I can. So I'm going to use the change of base formula, taking log of x and dividing it. Whoops, forgot to put the log of x in parentheses. Sorry about that. Log of x and dividing it by the log of 4. So if I look, I have the points given to me from the XY table, 1, 0, 4, 1. Sorry, I'm trying to make that show, and so on and so forth. So you can always check, again, using Desmos that you are on the right track. Are using Desmos, I'm going to follow that up with the second question. So given these two functions, I'm going to write it out because I didn't actually see the negative at first either. So 2 to the negative x power, and then g of x equals negative square root of x minus 2. So what I'm going to do is I'm going to analyze the key features they have in common by checking their graph. You don't have to graph by hand, you can use Desmos. Using Desmos, I'm going to type this in. The first function is y equals 2 to the, remember shift and 6, to the negative x power. That's the graph of the first function. Press enter. and you're going to type in y equals negative. And then to signify square root, I type in SQRT. Square root comes up. And in parentheses, because the whole expression is in the square root, I'm going to write it in parentheses, x minus 2. So these are the two graphs I'm going to be analyzing of what key features they have in common. And one thing I do note is that both in green and in purple, their domain will continue from 2 to infinity. So that's one thing they have in common. The x values are being used from 2 to infinity. And if I also look from 2 to infinity, the green graph, remember we read from left to right, is decreasing. It's going downwards as I go from left to right. And the same thing is happening with the purple. So it's decreasing, it's going downwards as I head from left to right. Those are the two things I'm going to note about the key features these two functions have in common. They have a domain that goes from 2 to infinity. And mind you, you'll probably see this in sentence form, but I'm just writing abbreviated what's happening for the key features that they have in common. And it decreases. Both functions decrease from the interval. Remember, intervals we write as the x value. So it happens from 2 to infinity. We read from left to right, so x to all the way to infinity, and we notice it decreases as it's going downwards. All right, guys, I hope this helps.